Okay, so today we'll start looking into the Linux, but I feel for people who are not, maybe people who are just seeing it for the first time, or people who have started seeing this whole conundrum of the Linux quite recently, they might struggle with the terms that is used within the Linux. So I'll draw a comparison between what we have been traditionally using, or we were operating system that we feel comfortable. I mean, I know a lot of people in the state use Mac as a desktop, but Windows is the unprecedented leader as things stands right now for the desktop world. People are and companies are also shifting to Mac, but Windows is it's a very versatile sort of thing. Like you can get any hardware, you can get any. You can just run that application on anything. It's quite economical as well and cheap, compared to the Macs. Because in Mac, you pretty much have to buy their hardware. You don't have any option that you buy somewhere else's hardware and then you run that operating system. So Windows is our operating system for the desktop world, at least, that can run on any different hardware. So you have so many different hardware companies like HP, IBM, Dell, Lenovo. They all are manufacturer of the hardware, and you can't use Mac on their hardware because they are stubborn that if you want to use my software, then use my hardware, right? So that's the another reason why, because company have some tie-up with between these vendors. Like I am the organization, I have a very good tie-up with the that go way back in, I have like 50, 60 or 30 years of relation with the HP. So I would take all the hardware from the HP, even all the employees that are using. So that has been one of the factor why most of the organizations have Windows, because in terms of the price nowadays, at least they are on the same in the same category. Whether you go for a laptop that is manufactured by some so here the business class laptop, I'm saying the laptop that are actually manufactured for the home uses, they are not very good. But the business class laptops are actually can give a very good competition to the Mac as well. But the good thing here is whatever I'm going to be listing down here for the Linux, because this side of the thing is the Linux and this side of the things for the Windows. So I'm assuming you guys have had a lot of interaction with the Windows, and you have spent a good amount of time, because even you guys don't know a lot about IT, but since you have made up your mind to come into IT and do some IT stuff, so I'm assuming that you have some better understanding compared to the person who doesn't do anything in IT. Even the person from the sales, from the marketing, accounting, or any other domain, they would also have to use the system or computer at some point of time, and they should have some basic understanding, whether they are just they're just around with just doing the bookkeeping stuff, but still they have to interact and they know the stuff. So first thing, we know in the Linux that it is open source, and we know what is the meaning of the open source, and it is also enterprise as well, right? But on the Windows, you do not have anything, at least from the operating side or operating system. While you do have packages or software that we call it, those are open source as well, which is supported on the Windows. But the operating system as a whole is not open source. That is enterprise, right? So Linux actually have a lot of open source than the enterprise. And we know why people are using enterprise, because they want support. Anything goes something in the middle of the night, who's going to correct that, right? How do you take that into account? So what organizations happen, a BCP, which stands for business continuity plan. Ignore the typo if I'm making any. And the disaster, DR, disaster recovery. I mean, these are the plans where there is questions like that. Something goes in the middle of the night. How do we ensure that our application is going to be up and running? What is the plan B for us? If plan A is that everything is running on this system that we have just configured, but if this was to go down with the bug in the system itself, or something can go wrong with the power supply or all the components that are supplied to that. So that is the one thing. The other thing could happen is the natural calamity and the disaster. So those sort of system and everything, the like most of the questions of the BCP and DR is your support, because you have the support, and from whoever you bought that particular application, whether it's from the Google, AWS, Windows, they are actually giving you a surety that I'm going to keep my best persons up with you until this issue is resolved. And if you're going to raise someone like a P1, then you have a solution within 12 hours and you have a response in an hour. So this is also a thing that people struggle. I mean, the new people, because I train a lot of freshers as well, and I understand when freshers who are just the people who have just finished their degree and they try to get into the IT and they get a job, they struggle with the terms of P1, S1, and all this thing. They don't know what is this. So P1, P3, and you also have S1, S2. I mean, these are like a priority and severity, right? Very common, but sometimes people struggle when they have to work with the support. So with the enterprise, you have a support, and that's the thing. With the Linux, you have both open source and enterprise. The another thing is on Windows, we have something called folders. We know what is the folder. Is just a container which will hold another files or another folder. So inside folder, we can have more folders, or we can have files, or we can have some application itself. We can package them, and that way that application will have it will be with some extension. And in Windows, extension is emphasized a lot, because Windows actually would understand the files based on their extensions. Whether, if you have the executable file, then you have to call it .exe. If you have a batch file, then you're going to have to call it .bat. If you have zip file, then you'll have to call it .zip. But on Linux, the extension doesn't have a lot of significance. If you put that, which is good for a human's perspective, from the developer or admin who will be interacting with that system, they can just look at the file and they'll be able to tell, okay, this is the zip file, okay, this is the executable file, or whatever the file it be. But in Linux, at least as far as Linux is concerned, Linux don't care about the extension. You can create any file and put it any extension. Linux will do its job properly, and that's the reason why in Linux every file starts with the header, which is called interpreter. Something we'll see during the shell scripting classes. So in Linux, same folders or directories, same folders are called directories here. And you'll hear a lot people talking about that in Linux, everything is a file. Anything that everything in Linux is a file. I'm just going to write this down, because you'll hear a lot, and we'll see that as well. Pretty much everything in the Linux is a file. You want to work with the network, you want to work with the security, you want to do the development, you want to do some application hosting, or some other kind of a database thing. Everything you have to do it with a file. There is you just go inside a file and you can do that. Even the directories are actually called file as well, because directory are the special kind of a file in which you can host more directories or more files. Like inside files, you can have a content, but inside directory, you can have a more file. So this is a special kind of a file which will have more files, which is a very generic or very common definitions. So of the directory in Linux, that is a very common line that you hear a lot. People saying again and again, everything in Linux is a file. And that is actually true, because when we go and interact with a different kind of application, we'll see that as well. Pretty much all we have to do is just find a file, a right file where we can put the right configuration, and that's it. We are done with it, right? So files are called files on both the sides. So we can have the files, Linux and Windows. The only thing here is the extension have a great emphasis, while on Linux it doesn't have a great emphasis, at least as far as the Linux operating system or kernel is concerned, because they don't care. Even if you put a wrong extension, still it would work fine, because there needs to be an interpreter inside that, and that's actually Linux uses to understand what type of file it is. How do I run that, right? So next thing we have is a software. We call on the Windows, we install different software. Something on the Linux, we call them packages. And if you are using mobile devices like Mac, iOS or Android, we simply call them apps, like application. So that is also a term coming from the Linux. In Linux also, packages, applications are commonly used. Here, in order to install the software, generally what we have is executable files, or what we call them installers, right? You have like exe file, double click on those, and then a wizard will come, a wizard will pop up and will take you through the installation process. Where do you want to install it, and how do you want to install, what are the customization you want to do it, all sort of screen, the multiple screen, it will take you through, and then the installation will begin. So that's how it happens. You do a manual interaction, and normally the installation are happening with the installers. On Linux, while we can do that with the installer as well, but generally Linux has something called package manager. We'll talk about package manager as well after the comparison. I'll show you, we'll touch base upon that. And Linux has Linux has installer as well. We can also install installer. The common extensions for the Windows, right? The two types are very common. You can have the file called .ext, and you can also have the file called .msr, right? Based on what type of application you're using, and you can also have some other, but these are very common file. Installers will have like a packaged, and that's how you're gonna have it. While on Linux, the installer that we have, they're gonna be of a different type based on the different flavors or distros of the Linux, right? We talked about that in the last lecture, right? Day before yesterday. Linux has different distributions and different flavors, and the common ones are, actually there are only two common ones. Like you have a Red Hat family and the Debian family, and then you have a SUSE and others as well. But those are not that predominantly used in the industry. Only Debians and the Red Hat ones are used. So for the Red Hat ones, if you have an installer or a package, exe is nothing but a package. You use some kind of a tool, you have a bunch of .NET or C# or whatever the Microsoft programming languages are used, right? Even the Python and others, you can have that. And then you just have to package it, compile it, and you create a .exe file. That's it. If you're using a Java, the traditional way, Java, you can compile and package. You'll have a jar file, which is called Java archive, right? Here, based on what distributions we are using, if we are on a Debian file, then it's going to be Deb. That's, all the Debian families we have. In the Debian family, we have Ubuntu, and then Ubuntu have a lot of flavors as well of its own. Then we have Kali Linux, Backtrack, used for ethical hacking. And okay, just give me a minute. Okay, and then for the for the Red Hat based families, we have RPM, which is called Red Hat Package Manager, and then the others as well. You're gonna have a different one. Okay, so these are the ones, but you not gonna interacting, or this is not the way we'll be more often than not. We won't be using this. Rather, we'll use package manager, and we'll talk about what are the package managers just in a bit. Okay. The other things in Linux or on Windows, you have a primary when you need. Just give me a minute. Somebody's calling me. Okay, so yeah, all right. So other than this, other than package manager, the one more important thing to know is the drive where we save all the content. Everything, the software, the files and folders, we need to create somewhere. We need a storage for that, right? And for that, you want to remember the resources that I say again and again, the 4 resources that makes up for the IT IT applications or IT resource. Within that resource, we're going to have 4 resources: the computing, storage, and the NIC. So here comes the storage. And by default, if you don't create a partitions, like just a separation or isolation between you can create different isolations as well. Those are logical isolations, but physically you're going to have a one hard drive attached to that. So the storage are always mounted. The word is mounted. When you actually attach that, you're going to have to mount it before it becomes usable to you. Those are mounted with on the C drive, and the way it's actually written, that is also important. It's a C with a backward slash, colon and backward slash. Another thing that we need to know, that in Linux, the file separators or the drive separators, in the path are backward slash. And because Linux or Unix came first, they started using a forward slash. So they have the forward slash, which is this. The people, the new who are coming into the Linux and they are used to Windows, this is the very common mistakes that they do. They get confused between backward slash and forward slash. Only thing you have to remember, which operating system came first, because forward should come first and backward gonna come secondary, right? So you have the forward because Unix came first and Linux is actually coming from the Unix, something also we have seen it. I mean, it's not directly coming from it, but it is actually coming from the Minix. Minix was inspired by Unix. So it follows the same file hierarchy or the file system as well. So just have to remember which is the first one. Linux is the first one because coming from the Minix, Minix is coming from the Unix. And so you have it here. Windows came much later. I mean, it came about like 15 years after the Windows, after the Unix was became portable as well by Dennis Ritchie and his colleague. So you have always forward slash. So no mistake, because you know how to now recall this. You don't even have to memorize it. Just understand it conceptually, logically. That's it. That's more than enough for you to remember, and you'll never make a mistake. The other thing we have here is called forward slash, just a forward slash. Now this time, this forward slash is with a very special purpose, because this one and this one, they are two different things. Because when you have forward slash in the beginning of any path, that means it's a root. So in Windows, this is the drive where everything starts from. On Linux, forward slash is the directory from where everything's going. This is the name of the directory. This is also the name of the folders, right? Because we are in a Windows world, we're going to call it folder. We are in a Linux world, we'll simply say this directory. So this forward slash is right now the first one. When you see in any path, right? Anybody gives you a path, the first forward slash is the root, and after that is the separator, and that is the forward slash. I mean, you don't call this forward slash as a root, because that comes after the forward slash, the root forward slash. And here the file separator or the path separator is backward slash. So you're going to have C colon forward slash and then some directory name, and then backward slash, then another directory name, then backward slash, then another directory name. That's the way you're going to have it on the Windows. Here you're going to have forward slash, which is the root, the name of the directory, then again forward slash, that would be a separator, and then some name, and then again if you have a very long path, then you're going to have a lot of separators there. The another thing here, the admin user or the user with the elevated privileges, right, or super privilege or super user, simply put. Super user here is super user in Windows called administrator, and super user here called root. So one more one very interesting thing, or something comes as a quiz for the Linux. How many roots are there in Linux, right? So far I've showed you two roots, right? One is here, another one is here. So there are total two roots. First root is actually represented by forward slash, which is the starting point of the directory structures on your system. Second is the user root, because this is the user or super user, right? This guy is a user. Same as you have administrator user on Linux, we have a root user. Okay, and there will be a one more root. We'll have that just in a minute. We'll see that. So these are the few things that you want to know while working with the Linux. Say the names and the stuff. So while I have actually written the installers as well, but we won't be interacting with the installers. And there are, we actually want to dedicate a couple of lectures talking about the package managers, and where we'll see when to use. And I mean, using installer would be your secondary choice. First choice will always going to be a package manager, and we'll see that in a great detail later. Now, but for now, just you should know that there's something called package manager. And based on again, in Linux, the one thing that you have to remember always, because based on what type of distribution you are using, few things going to change. The foundational is going to be remain same, but because that's a different flavor and they've added something new to that, that's the reason they are calling it a different name and then selling it to you. So while everything in Linux going to be the same, and for that, Linux have actually came up with a term, or they've actually created so the whole Linux world, there is a notion of something called POSIX, which is very important. Let me just write it down here. Now, while POSIX stands for Portable Operating System Interface Experience, I think so. Right? You don't need to know the full form of it. As long as you understand what is the POSIX, that's actually good enough. So the meaning of the POSIX, in a very simplistic way, if I put it very simple, if I were to put it in a very simple term, and that's what I normally like to do, so you guys can understand. Anything that you can run on Unix, generally. Okay. Okay, I think sorry, am I audible?
Yes, right now you're audible.
Okay, there was some glitch in the network. I got dropped out. Okay, so I was saying in Linux, there is something called POSIX, which stands for Portable Operating System Interface Experience. And while the formal definition is very fancy and not very easy to understand, so I'm gonna just break it down for you. And what generally POSIX are something which is similar to Linux, or Linux-like systems are they are POSIX compliant. Any operating system which is if any operating system which is POSIX compliant, which means whatever you can do here, you can do it everywhere else. Like if I'm running some command called ls on Red Hat distribution or CentOS, is that same ls command, that actually should start with the Unix. So if I'm running ls on Unix, if that same ls command is working on Red Hat or Debian or SUSE or whatever we have, Slackware and all of those different distributions that we've seen, right? More than 10,000 different operating systems, probably 100,000. I don't know. It could be close to that, because everybody can go ahead and clear their own operating system. So any command that works on Unix and the same command works on any other operating system, that operating system is the POSIX. So any OS to be POSIX compliant, they need to support the same command. The reason why they had to do this, because everybody is coming up with their new operating system, in few years time, and there is so much a man can learn or human can learn, right? Even the geniuses, they don't want to work with, like I have spent my 10 years working on the Unix. Now all of a sudden the new operating system have popped up, and I don't know how to work with that. All of a sudden I've become fresher. I have whatever the knowledge that I've gathered all of these years, it's used this now because I need to learn something completely new. And so that's what the IT they have actually done something for the container as well. They've created a similar compliances for the container world as well, because different Docker came up and Podman came up, then Rocket and all of those. So they want to have a common ground where if you learn one container language or one way of container working, then you can work with any other maker of the containers as well. Similarly, if you are able to work with the Unix, you should be comfortably able to deal with that. Now you're going to have some variations and slightly changes, but core functionality should remain the same. The basic navigation should remain the same. The way you do basics activity, that should also remain the same. Now you can have a different locations, you can have a different packages or software on top of that, but these are the common commands which will help you to understand or work with the operating system. That should remain the same. That is the whole idea with the POSIX. So POSIX, like any operating system that is Unix like, which supports the basic commands or basic functionality of the Unix, that is the POSIX compliant. And with the example, in Unix system, I can run a command called ls, and that command would show me everything that is available in the directory, right? So if I go inside any directory and if I run the ls command, I would be able to, I can see the content of the directory, and the content of the directories are nothing but going to be more directories or files, right? Content of the directory, that's what the directory is going to contain. Now, content of the file is going to be the text, because it will have some text, it will have some number. So there's a different command to use that. And then, I mean, even so, I can use the cat command here. And if cat command works here, and if cat command works on any other operating system along with the Unix, then that operating system is the POSIX compliance, right? Now, Windows is not a POSIX compliance, even though if you were to open a PowerShell and you do ls, that would work, right? And you might wonder why then Windows is not a POSIX compliant, because it's not a ls command. They've actually created a aliases, and the command is something else, because they know a lot of people, they are trying to make it more like a Linux shell, but they've always been on the other side. Like I said, they've always the one who opposed Linux, but they had to do it because the whole world turned to the Linux, at least the corporate world, right? Even they were able to dominate the end user side because they were always in user friendly stuff, and they make their operating system very bulky with the graphics and all. But that actually, for the enterprise application, your server is just lying there somewhere in the data center. Nobody's going there. You just run your application and that's it. So why do you want to add so many graphics stuff that actually going to eat up a lot of your resources, and eventually it will become very slow. So that's why Linux gained a lot of popularity, and a lot of companies started using it, and it's a dominant one. So they had to do these changes. Windows started the development of PowerShell somewhere around 2005-6, and 2009 or 10 they added to their operating system, and then they added aliases as well. So while you can run the ls command on the Windows, cat command, all the common command, right, or at least all the commands that is available in all the POSIX Unix-like system, they have added those as an alias. So in reality, when you run ls on the PowerShell, a different command is being executed. It's not ls command, it's something else, but because they have created alias, now you are able to do that. So Windows is not a POSIX. Mac is the POSIX, because Mac can do pretty much everything what Unix is doing, because it's also driven from it. BSD, AIX, I've showed you that that all the operating systems that have emerged from the Unix, those are all POSIX compliance operating systems. So it's a very important word. Like, while you're going to have all of these common things, the one thing that will be different is not everything's going to be the same, right? You're going to have at least basic by which you can actually get started with, or you can deal with that operating system. But based on what distribution that is, it will change, and that starts from the package manager. So the package manager that we have, package managers, I'm only going to list the common ones, right? So again, Red Hat, will list the Red Hat and the Debian, and we'll also see the Windows. So Debian and Windows. In RHEL or Debian, what package manager is, all the software, like we have to download the exe file here on the Windows, right? And then I need to run it. So I'm going to have to download it from somewhere on or from some site, probably the maker site, like whoever is making it, they're going to make it available on the site to download it and then run it and then use it, right? That's the way it happens. So in the concept of package manager, what happens, there is a server dedicated where you just store all the packages, and the package manager that you are using, that package manager is going to go to that server automatically. You don't need to tell that server. I mean, you have to, but there are because the package manager, whoever has created that package manager, they're going to be maintaining some servers or some packages from where you can connect and do that. So the job of the package manager is automate the installation. automate the installation and basic configuration. That your package manager is going to do. That's a very simplistic definition, just so you understand. We'll talk more about package managers and we'll do some labs as well on the package manager. But here, one thing that the very common mistake that people use is, right, I'm going to, so package manager, here is the RPM and here is the dev. And in Linux, there are a few, we have, again, a few that are developed by the community, not is coming shipping off by the operating system default, right? These are coming from the operating system. If you are working on the Red Hat operating system, you don't need to install RPM. It's already there. If you are working with the Debian, you don't need to install Deb, because it's already, it's not Deb, it's actually DPKG. The name of the files are, it's a Debian package manager, DPKG, and I mean, these are the commands, this happens to be the commands as well, and it's a Debian package and it's a Red Hat package manager. On Windows, that same thing is actually by Chocolatey, and then there are a few others as well, but Chocolatey is very famous. Like pretty much everybody uses Chocolatey on the Windows to automate installation and basic configuration of the packages. You don't need to install anything from the maker side and then run the installer and then configure it, the basic thing. Everything is automated. Now, how you, so these package managers have a high level utility. High level utility, we'll talk about those, right? But for now, just remember that if you want to work with RPM package manager, all you have to do yum install package name. So if I want to install whatever package, if I want to install, maybe I want to install VS Code, I'm just simply gonna do yum install and VS Code. It'll install that. On the Debian based system, the same thing actually becomes apt install and package name. So this is the difference now. So people who works on the Red Hat, because they're used to using yum command to install the packages or install the software. Suddenly they are using a Debian system and they're gonna try and use the yum, because the RPM or yum is not available here by default. While you can configure that, but nobody's going to recommend to do that to you, because Debian already comes with its own package manager. So why not use that instead of, again getting all, just because you are comfortable with this yum, it doesn't necessarily mean that you, get those complexity. It's not that easy, right? You have to understand what is expensive or what is feasible as well. Here you already have something, so why not use that? It's a conceptually same thing. And that's the reason why I put a lot of emphasis on the concept, because if you know the concept, you know what to do. Just change the steps or change the, you have the UI, whether you go to Amazon or some different shopping site, you know how to actually shop. You're going to have to select the product, you see the reviews, then you add it to the cart and then you check out, right? That's the process. Now, based on which vendor you are actually trying to buy it from, the website's gonna, it'll have a different look and feel. It'll have a different button, probably different names as well. They might put a different name if they want to do that. Like for the cloud, for the instance, right? On AWS calls the server that we create. AWS is gonna call that instance. DigitalOcean, same thing, calls a droplet, right? So they put a different names to the same product as well, just because they want to sound different and they don't want to copy. As simple as that. So that's the same thing you have. So always try to understand it from the conceptual side rather than the step side. Because if you follow the steps, then you're going to find yourself in the middle of nowhere or stuck, that you probably feel, okay, there's no way out and I don't know stuff. So it's better always understand, get a conceptual understanding, and then there is a package manager. Package manager's gonna have some high level utility like this, which is gonna automate everything for you. We'll talk about RPM, DPKG, and the concept behind this as well. But right now, just remember that this package manager, this is what they're doing. In Chocolatey, this is community developed and it's being funded by the Microsoft as well, but it's not something coming by default. Maybe they will add it into the future operating system or to the server. I don't know that, but at least things stands. It's not by Microsoft. It's a work done by the Windows community, right? And Microsoft have actually trying to make up things as well with the open source people, because they don't go very well because they have a very they don't have a very good history with the Microsoft, right? because they were the opposing party when all these movements started. So they are trying to make it up, and they are doing all the contributions with the cloud thing and a lot of different changes. But things gonna take take a little time. Why, when the open source community, the animosity goes away. So and one of the recent example was the GitHub acquisition. When they acquired GitHub, all of these open source projects which were majorly hosted on the GitHub, they moved to a new site. They actually formed something called GitLab, and GitLab is now is like your CI/CD, is turning out to be the leader in the CI/CD world. It provides all the modern stuff, and so that's what happens, right? That's actually shows how much open source community hate, or they don't like stuff done by the Microsoft. So they don't have it, but again, they're making up. So you have a two sort of schools of people, and they've developed it. So if you want to install something here, it's going to follow a similar syntax or similar way, just choco install and package name. So one difference that you see when you are working with that, because this concept again is derived from the Linux concept, right? I mean, chocolatey is like a very recent movement or something started. It didn't exist like how we have a package manager in the Linux. So one thing that you know is you're gonna have to change the yum or apt or choco. The rest of the thing remains the same. The another thing you're gonna have to change is the name of the package manager as well, because Red Hat gonna call that same package manager by some different name, and Debian gonna call that same package name by some different name. So the way this thing happens, instead of whatever the package that you have hosting, normally what happens, we go to the maker's website, whoever made that particular product, we download the exe or MSI, or if you are on a Mac, then we're gonna download the appropriate Mac file, and then we'll install that, right? What in the in the sense of package manager, the Red Hat people or the Debian people, the community itself, they will be maintaining this software, and they're gonna bring all the software that they wanna support, and they'll put it here on this software. So if this, let's assume that this server is maintained by Red Hat, the Red Hat people, and so they might call this rel-vs code-1.2, something like that, right? .rpm, because all their packages gonna have the extension of RPM. Same thing if Debian community, if they also have VS Code, a same package, which because the package is open source, so they're downloaded from the Microsoft website and they put it here. They might call this simply, they can call this VS Code 1.12.dev. I mean, even though it's like 1.2, but they might put it this way. Now these are the same two packages, so the package name gonna change whatever you have here. So there are so many commands to actually to find out what is the name of the package. You can do yum search and then some patterns to search it, app search or choco search. You can do that. So that's actually gonna change as well. So if you have a script that you were used to running that on the Red Hat system, and the command was yum install rel-vs code 1.2. Very common is another one is here for the http .rpm, that's what we call it here. And on the Debian, the same package is called apache 2.dev. So if you want to install a web server of the Apache on the Debian, you are going to have to say it like this: apt install apache 2. And if you want to install the same package here, then you're going to have to call yum install httpd. I mean, this is the actually example. This is the current scenario right now. I mean, this is like something, it's a hypothetical scenario. So this may not exist, but you're going to find a difference like that. It's just for your understanding, right? But this is the actual ones we have. If you want to install a web server, Apache 2, you have to go by that name. And if you want to do that, then you have to go by the HTTPD name on the Red Hat systems. So that is the difference between package manager. We'll see more about the package managers during the lecture when we will do the discussions about that. Now, one more thing that we need to understand before we actually jump onto the lab and start doing stuff is the file structure. right? So we'll start with the file structure of Windows. So on Windows, what we have is called C drive, right? Let me put it up here. We have something called C drive. And on the C drive, if you can recall, if you have worked with the Windows, first directory that we have on Windows is of something called users, right? And this is the directory where we're gonna have all the users, and starting from the main user that we have, which is administrator user. If we have enabled it, then we're gonna have a user called guest. I mean, these are the two common users that you're gonna have in the Windows, right? Administrator and the guest. And if you want to have, a specific user for a specific your user, then it will be here. Let's put it like this, John Doe. So on the Linux, in the C drive, first thing you're gonna have is called users. Second important thing that you might remember, it's something called program files. And the name suggests the program files is where all your configurations or the application that you've installed. So this program file contains config files, data files, right? For the application specific, right? Any application that you install, it will go and live here. Now you have program files and program files 86 as well. You're gonna have that. And then we have something called Windows, another directory called Windows. In Windows, there are few directories, and one of the important directories is System32, where you're gonna have all system related, the whole operating system that is installed to you. System32, a directory like that, and then you're gonna have a bunch of files there as well. And then another file we have, normally you'll have here is a temp, where you're gonna temporarily store the data. And the same you're gonna have inside the Windows as well. There are two types of temps, but let's not get into that. It's just a basic file structure that we wanna see. So this is something you can relate, you can imagine in your head. Okay, this is the file system, this is the file directory. What we have in the Windows, in the C drive, we have now the E drive, D drive. These are like a user created drives, right? So they can vary. Now you're just gonna have a drive, and whatever directory you wanna create, it's free. So that's the reason why I'm not taking D drive and E drive, because most of the time in the most operating system, you're gonna always create a logical partitioning, right? You're gonna divide that, and if you have like a hard drive of 1 TB, probably you're gonna split it 500 GB to the C drive and 500 GB to the D drive, something like that. You do that, and whatever you put in the D drive, that's completely user specific. Whatever the way user wanna organize the way he keeping his files, he'll have it that way. And in the user, in the users, you're gonna have then a desktop. You're gonna have documents, downloads, and a few other stuff. You have things like that. So we're gonna have for desktop, then documents, my documents, right? Things that we used to call, and then downloads, and bunch of hidden files as well. We're gonna have that, and then whatever user creates it in the desktop, user can store all the shortcuts for the application that he wanna runs. In the documents, maybe you wanna store all the files. In the downloads, whatever you are taking, downloading it from the other sources, like from the internet or from some different server on the remote, right? So that's the structure we have for the Windows. Let's talk about the file hierarchy or file structure for the Linux, which is very important, because most of the time that we will be spending is on the server, and server doesn't have the GUI, the graphical thing. All you have that terminal, and you just use the commands. And if you don't understand the navigation, then trust me, your head will start spinning, because that's what happened to me as well when I was learning Linux. I never used to understood the navigation. I mean, it came with the struggle, and I didn't have a person who would actually break it down for me and do a comparison, because I was using Windows at the time a lot, and I was not very good with the Linux. But the struggle that I came up with, I just don't want you guys to go through the same struggle, and I'm trying to make it as easy as possible, so you can put a lot of concentration. You don't lose the concentration, because in my life there have been a period where I thought, okay, this this thing is not for me. Probably I can't do this because everything is happening on the screen, which I don't understand. There are a bunch of commands, I see on the TV, and a lot of hackers, they use those screens. The numbers are just popping up, the letters are coming up. So there was a situation as well. And once you understand this, you're gonna fall in love, because that's what happened to me. And I'm still in love with the terminal. I prefer, or I feel more comfortable working from the terminal than working from the UI, because once you understand the benefit of it, how powerful the terminals or the CLI becomes, then you're gonna use that, because it's gonna save a lot of your time, a lot of your effort. It'll give you a lot of flexibility, a lot of control, so you feel very comfortable, because that's what I feel. And that's the same story anybody can narrate as well in the Linux world. So the first thing that we have, similar to the C drive, everything starts in Linux. And I say everything, right? There is pretty much everything gonna start with a /, and this / is your root, right? So root is the father of all the directories in the Linux. You can actually call that. So everything in the Linux starts with the root, and then there are a few important directories we need to remember. Just like we had a users directory in Linux, for the users we have something called a home directory. And because Linux is not like very English thing, it's more of a technical or geeky. So you do not have Linux with the capitalized or spaces. You're always gonna have small letters, camel cases, snake case, kebab case. There are different types of cases out there, right? You're gonna have underscore, which is your snake case. So we have something called home. Home is the directory. Now we're not gonna call these folders, because in Linux everything we call it home. And then within this home, you're gonna have all the users that we talked about, except the root user, right? We talked about the root user, which is similar to the administrator. On Windows, you have the administrator user also in the in the user directory, where the rest of the users also going to be present. But on Linux, that root user is actually given a special place to for his all the staging area. Basically, this is the staging area for the users. Admin user, whatever you store on the admin user's desktop, you can't see that from the John Doe desktop, right? Because this desktop is different, and this desktop, whatever you're gonna have here desktop, that is different. So this is the staging area for that user. User can store its stuff there, and there could be another user, and his desktop documents download will be completely different, and John Doe can't see to that particular thing. Administrator can't see that. I mean, administrator can see that because he's the super user, so we can use his power and see that. But by convention, that's if he just normally try to see it, he won't be able to see that. John Doe won't be able to see to the admin directories content or any other user that are present. So that's the you have. But the thing is, we have everything, all the users, whether it's a super user or guest user or a normal user or even the service user. We'll talk about the different types of users as well. You have user account, service principal, user principal. Those just fancy terms. Later, like for now, yeah. So here you're gonna have all the non-root users, all the users which are not root. So I can have the same John Doe, but I shouldn't put a space. Now this is a snake case, right? This is the way I'm gonna have it, and I can have another one, Jane Doe. This is the camel case. So just giving you the feel of the different types of cases that are there, right? So you have camel case, snake case, kebab case, and there are a few more as well. So this guy gonna have it, just two users will be here. And for the root user, we have a special directory dedicated, and that directory is called root itself. So here is your third root. Like I said, the Linux quiz is very common. That talks about what are the three roots in the Linux. First root is your this thing. Second root is your user. Third root is the directory or home directory of the user called root, right? So this is the root user root directory. It is not a user. It is not the parent, right? Parent of all the directory or all the file system in the Linux. So you have it here. So this, whatever the root user stores, it will be stored here. Whatever the John Doe is gonna store will be stored here, and same goes with the Jane Doe. So that's the that's the thing we have. Now another one, or I mean there are so many are there, right? But we only gonna touch base on the important ones, or the ones that normally you should know while working on the Linux. And something also, if you taking an interview, they might ask you during the interview as well. Okay, tell me about the Linux file structure, and you should be able to say that. Okay, Linux contains a root directory which is represented with the /, then followed by home directory, the root directory which is for the root user, then the next one that are coming up. So that's the way you should give the answer, because if you are going for a Linux basic, I mean, if you are just going for any kind of interview and you say Linux, because that's going to be something expected from you, and they might or may or may not ask you that question. It's going to be just one or two questions, but it will come up, right? Because that's everything is hosted on this operating system. The next one is etc directory or etc directory or etc directory. Now, based on again just how there are different variation of pronunciation for the Linux, and Linux. Similarly, people gonna call it with the different pronunciations as well. Some people, if you based on which region of people you are interacting with, that's what I've seen in my opinion. And people in the States, they simply call this etc, and rest of the world they are calling it etc, right? So you can call this etc directory, etc directory, or etc directory, right? It's all the same thing they are pointing to. So this directory in the Linux is where you're going to have all your config files. So any application that you install, all the config files will come here, and this is very, very important because you have to deal with it a lot. Okay, so I heard a disturbance. In case you have a question, just have to raise the hand. That's it. Then we have another directory called USR, which has a very good, bit of a history around it. USR is now stands for Universal System Resource, but originally, actually, this was similar to this directory used to call user, but they wanted that it was just for the user. They just took out the vowels out of it. That's the way you'll see the programmers will do. If they want to put any name, they just remove the vowels, right? If they want to name, and in program you might see nm like that, because they've taken off the vowels. That's a very basic way to shorten the names in the programming when you're writing the name of the function, or you're writing some some similar stuff. That's the way you do that. So USR is the original intention back in the day was all the users can be stored here, but over time that need changed, and they had to separate it out because they were storing a lot of data files here. So this stands for that. There are a few different opinions about what is the full form of this, but this is like very commonly used: system resources. And here you're going to have all the data files, for application application will use a lot of file where all the application data will be stored, and then all the config files will be here. So that is just to put isolation. So anybody knows Linux and you ask that person, okay, go and troubleshoot this, first thing he will try to look into the configuration file, how this application is configured. You want to tweak something of that application, you'll have to change the configuration, and that configuration will be present here. Like if you are working with the Nginx, you install the Nginx, all the config files will be dumped here, all the data files will be dumped here, and there's another one called binary. All the binaries will be dumped here as well. And binary is the one actually that will allow you to run that particular package. So there is another directory which now binary is present on few locations along with the directly on the root. So any path that you want to construct now. So if I say, okay, let's go into the let's go into the John Doe's directory. Now your path gonna construct from here. So you're gonna have / home and then John Doe, like that. So this is you have it this way, and then there are another one. There are there is another important one that we use very commonly is called TMP. And then within the USR also you have TMP, you have bin, you have local, you have cache, and a few other stuffs. So you can have that as well. And there is a temp directory is just to hold the temporary data, and then we have something called var, which is a variable where you can store system, just a var directory. And this var directory also present in the USR as well. So you have this, and then there are device and boot and few others as well. This device is something you can relate, like every time you attach a device, whether that is a pen drive or some kind of external device, it's gonna be inside the dev. And there is something called proc. All the process that are running, we'll talk about this. We'll talk about the proc because that's important for us. Device is not very important, and etc is very important, user is important, and all these the ones that you have. Proc is in short for the process. So in Linux, everything is running on the process, not just in Linux, even in the Windows as well. You have a task manager. If you open up the task manager, you'll be able to see what processes are running. When I'm running this Paint application, there is a process of the Paint is running in the backend, right? So that's how things happens. Right. So here, I think you the question somebody asked on the chat, Victor, is what is a USR, and USR.
Oh, you already answered it.
Yeah, I just saw that now. Okay, so so these are the file system that you want to remember, and I'll probably gonna ask this time and time again. Where do we put the configuration file? Where do we put the data files? Where is the temp? Where is the user directory? So that's the way you should remember. Maybe put a sticky note and just put it in front of your wherever you do the work. So that way you remember that, because it's very important, and it is the heart of the Linux that we will be working. So if you know this directory, if you can imagine this in your head in a graphical way, then it will become a lot easier for you to work. Because the next thing that we want to jump onto this is the navigation. And that is very crucial that we understand the navigation, because if you understand navigation, then it will become a lot easier for you to work with the Linux. But if you don't, and your head starts spinning just because you're not able to imagine where we are, because it's all going to be dark and gloomy, right? Just gonna be a black and white screen in front of us, and that's it. No graphics. We don't see that. We have to work is bunch of commands. There are like different variations of command, but we're gonna have to work with the commands. So the navigation is important in the Linux. And the next thing within this is the different types of path. So we have relative path, absolute path, and environment path. So environment.
Sorry, I have a question. I can't find the raised hand. Sorry. So I have a question.
Yeah, go ahead.
What about the OPT directory? And is it mandatory to use the OPT to download all the packages first and before moving to another directory? Is it the best practice to download packages in OPT? Right. And what's the purpose of that?
Right. So, okay, good question. So we do, like I said, there are a few others as well, and one of them is the OPT. And OPT, you may or may not find it everywhere. And like, it looks like you have some working knowledge with that. So if you are not working with the package manager, because when you work with the package manager, you don't need to download that, because package manager is going to take care of it. But for some reason, you're not doing that with the package manager. Something, we'll talk about that in the when we discuss package manager. It is considered to be the best practice that you do it here. And by the way, your application can run just fine by keeping it you don't need to put configuration file here. You can just put anywhere here. You can create in your home directory, and you can run that. That application would run just fine. But what you're not doing is the best practice. And when you don't do the best practice, actually you're going to make it difficult for some new user, because like I said, you are running some application from your home directory, let's assume, and the new person comes in and we ask him, because okay, Linux, okay, we are having this issue with this application, can you go and troubleshoot? So first thing that person will gonna try to do that, okay, if this is installed, let me see the configuration, and he'll go and try to look inside the etc directory or etc directory. He won't find the configuration. Why? Because you didn't follow the best practice or the common practice that a Linux user should follow. So that is considered to be the best practice. You have the OPT directory where you can download the packages, and then you can install that. And these packages, if you are not down, there will be some instances during the time where we might have to work with the application which are not hosted on the package managers. And by the way, most of the time that we work for an organization, generally the idea is we are working with a homegrown application that are internally developed, and it's homegrown. Our developer have developed it. So the Debian people, they don't know what type of application that we are working. So it is very apparent that they will not have that application on their server, and if that is not available, then these package managers cannot do that for us as well. So we can actually create our own repository server. I mean, these are called repository server. So we can do that. We can do this way, and then use these package managers to automate it. Otherwise, we can just follow whatever the way package manager does. We can do it our way. We can just pretty much follow what the steps package managers follow, and then we can download the whole package here in the OPT directory, and from here on we can take care of the rest of the executions or installation. Right. So that's another directory we have it. Okay, so coming back to, do you have any follow-up question, or I think that's good. That's good enough.
Yes, that's good enough. Thank you.
All right, so coming back to relative path and absolute path, right? So there is a very simple definition that you want to remember about, this thing, differentiating between what is the absolute path and relative path. And we'll see with a few examples as well. And absolute path is the best practice, considered to be the best practice to do that. And relative path is the easy hack, and it's going to save you time, right? And you should be able to actually calculate the, which is the faster one. Sometimes your relative path can become expensive in terms of you'll have to put a lot of keystroke, or you'll have to put a lot of the, a word on the terminal while you're working with a relative path. So it's not, relative path are always easy way out. Sometimes relative path can become a long route as well. So absolute path, there is a simple definition, and the opposite of that is the relative path. And we'll talk about environment path later. I'm just writing the different paths that are available, because immediately we'll be working with the absolute path, and environment path is just the absolute path, which is coming, with the environment. So any path that starts with /, that is your absolute path. So this is the part I have written, right? So it's starting with the /, which means this is the absolute path. Any path that doesn't start with the /, that is not absolute path. So if you have a path like this, like I'm saying home / John Doe, then this is the relative path. But there is a catch in here. If I'm gonna do something from here, I need to be present here. If I'm, that's the way it's gonna happen. We'll see that more into the class, but just remember the definition. That any path that is starting with the /, that is your absolute path. And absolute path is considered to be the best practice, and you should always want to put the absolute path while working with this. Okay, so right, so that's about the last bit. And before we actually go and work on the shell, there is one more thing that I should let you guys know, so you can imagine in your head while working with that. That is something called shell. We'll be working on the shell, and the way thing works on the Linux is we have the hardware at the middle, right, which has all the all the good stuff, or the hardware actually has all the with the blank one. So we have hardware, and then hardware interacts. We know the hardware interacts with the shell. So this is your shell, and this is very common way to explain. So it's interact with the kernel, and kernel interacts with your shell, and shell is the place, or shell is the program which we will. It's an interpreter, and that is available on the terminal. So we'll be working directly on the shell, and there are different types of shell as well. And I'll tell you a few shells, and then on top of shell, what we have is the applications. And all the modern applications that are available right now, all the application that is a modern application is thought to be, or that needs to have a three-way of interaction, or at least, that is what the modern applications have by default. So there are different interfaces. Like one of the interface is the UI, where UI is very good, is the user interface, right? As name suggests, and this is for end users. Then we have something called CLI, right? And this is for sysadmins, non-developers. Non-developers become sysadmin. That could be network admin, or it's security admin, or cloud admin, or any application specific admin. And then we have API, which are for the developers. So these are the interfaces through which people interact. And you can actually, if you work with the cloud, so there is a AWS console, Azure console, GCP console. You can click here and there and get the resource done. And at the same time, you can use the command line as well, AWS CLI, or you can use the API as well. There is a Boto library is there, and if you know the Python, you can do that. So if you're a developer, your tools are your programming language. If you are sysadmin, your tools are your commands. And if you're an end user, just a graphic and the UI, user-friendly stuff is your stuff. And to work with the CLI, where do we work directly is on the shell. Right? So users are working on the application, and working on the application is gonna slow us down, because anything that you pass to the application in the backend gonna translate your actions. Like I'm drawing this right now on the paint. Everything is actually converted into the some kind of a command or some kind of a program, and it's given to the shell, and then shell passes through the kernel, the instruction, and it gets to the hardware. And then from hardware, I get the response back. And because I'm trying to draw a line here, and I get that, it's rendered. Everything is happening in a millisecond, right? In a microsecond and milliseconds, so fast. So that's the reason I don't see that exactly happening, but that is the way. So working on the shell is faster. Why? Because we are actually reducing one hop. So instead of doing directly on the application, I'm doing it directly on the shell. And this is one of the reasons why you're going to fall in love, because when you do that with the application has to translate or convert whatever the instruction you have given. So right now, the instruction that I'm giving to the paint is just to draw the line. That actually converted into some kind of a program, and it's sent all the way back to my hardware. And then hardware has the capacity to draw the line or graphics, right? Because it's going to have some CPU and GPU. That's going to fulfill my request. It comes back through the through the doors, which is the kernel sitting in between, and then gets to the shell, and then shell takes application gets it, and then so the two-way process is happening, right? Gets slowed here on the application layer. So if I can reduce one hop, things will become quite faster, and that's what's one of the benefit you're gonna have. So we will be working with the shell. The shell directly interacts with the kernel, and then kernel interacts with the hardware. That's the way the backend thing. In the behind the scene, that's how it's happening. Within the shell, we have originally in the Unix we had shell, and then of this shell there are improved version of shell have actually been written. And the one that is very common is Bash, which is written by one of the programmer called Jason Bourne. So it stands for Born Again Shell. If you are working on a Mac, then I think you have Z shell or K shell. I'm not sure about that. I think you have Z shell, which is also very common. Then there is a K shell. Then there is a fish, and there are so many others, right? There is a fish. So these are the differences you're gonna have based on the different flavors of the. So while your core commands and functionality gonna be the same because they are POSIX compliant, but stuff like this, the shell, the package manager, the different packages to handle different things. I mean, you have a different command to work with the network on the Red Hat. You have a different command to work with the network on the Debian, because that is not a core necessity of that operating system. So you're going to have that different flavors. The Cisco have come up with their own operating system, which are again based on which are actually Linux, using Linux kernel. but they have taken out all of these stuff, all of this unnecessary stuff, which a network engineer might not need. So like they've taken out those sort of things. So that difference you're going to have. The most popular ones is Bash, which is used in Debian, which is used in most of the operating system. It's used in the Debian and Red Hat predominantly. And K-Shell, Z-Shell, I mean, they are also there. Like you have SUSE, which is also turning out to be the enterprise competitor, and different corporations they've started using it as well. So they use K-Shell. You have Mac that also uses Z or K-Shell. I'm not sure at this moment right now, but they are not using Bash for sure. So you have different shells, and there are going to be a slight variations because they are different. If they are different, then they're going to have something different in them. But again, because they have to be POSIX compliant, your core functionality needs to be the same, right? So we will be working on the shell, and we will be working on the Bash born again shell, and we'll use our operating system called Debian, and it's quite easy to get. It's my favorite way to actually get up and running with the Linux system on the cloud or on the browser. You don't even need a cloud account. All you need is the Google account. Google have been very generous distributing learning stuff for the education purposes. I mean, the cloud service was also something unmatchable a few years back, but now they have started limiting it. But still, compared to the others, they give a lot of facilities, because they are the company who have gained. The company actually they've become a leader because of the open source world. So they do a lot of contributions for the learning purposes as well. So what I'm going to do now, I'll head over to the browser and I'll show you how to get a Linux shell.
Quick question on this here. So the kernel, is it something we see it only on Linux? So do we have a kernel on Windows also, or it's just
Yes,
Linux?
we do. We do. On the Windows, we have the NT kernel, and on the Linux, so Windows also have a kernel. The DOS, what you have, right? You might have heard about the DOS. So that's actually doing.
Yes.
That's what you have to interact with directly to your hardware. And on top of that, you have the fancy stuff with the graphics and all, which actually allow you to work with that or run your application. So you have that concept everywhere. That's a very basic. So Windows uses NT kernels, and in Linux also there are different kernels and there are different tiers as well. Since our job, we won't be going into the kernel development. If anybody want to do that, you should start with the LFS, the one initiative that I've showed you. And then you'll see that there are different types of kernels as well. Within the kernel, you have so many different types. So Linus Torvald, the maker, he's a kernel developer. He's not like a sysadmin. He knows a lot of stuff on the kernel. So all the programs that he have written, and Linux kernel is written in C, and the Windows is also written in completely C. So because that was the very robust language around that time. Right now, Google makes a very good statement or something. Google says everything has evolved from 1960 or 70, since all this IT things started. Pretty much everything has evolved except the programming language. We are still using the programming language, which is 50, 60 years old. And they say that their programming language, which is a Golang, is the modern programming language, and it has a lot of. There have been there is a community formed which is doing a rewrite of the Linux kernel into the Go. I don't know how far they will go with that, but something I've seen quite recently, and they've started doing that. So yes, you have the kernel from the beginning, and even in the Windows we have it. The name of the kernel is NT, and since we won't be going into the kernel. But later, if you want, you could do that always, right? You have all the resources available at your disposal. All you have to do is time. Yeah. It's for others as well.
Last thing, yeah, quick one. So sorry, you mentioned the CLI acting on the shell, but what about the API also? Is it acting on the shell for the
UI,
developers? Right? Yes.
UI is actually your application.
No, the API.
API is also on the shell. Yes.
Okay. All right. Thank you.
Welcome. Okay, let's take the browser. Okay. So here I'm on the browser. I use Opera browser. So all you have to do is just search for a Cloud Shell. This is, just to get started with. If you wanna if you are on a Mac, you don't need this. You can pretty much do the labs on the Mac as well. But for some reason, you just wanna follow me and do this. And if you are using a Windows operating system, you can just head over to this one. We'll come into the installation as well. We'll even go to the cloud and we'll see the different, deployment on the cloud. But for now, this is the very easiest way to get started and get ourselves a server on which we can do, some hands-on labs. So we come to here. I mean, there will be a few things, that talks about what is Cloud Shell and all, something you can learn about that as well by going into the documentation. But to start your server, which is completely free, all you need is a Google account. Is just click on this one or this button that you have here, and this should populate, or it should ask your permission to launch. Yes, let's launch that. I don't need this one now. I can close this one now. My Cloud Shell is coming up. So this is just a machine, a server, and it is a type of Debian. So we know that there are different types of families we have. So this is going to be the Debian. It's not Ubuntu, so don't get me wrong. Right, Ubuntu is also coming from the Debian family, but Cloud Shell that we are using, it's just a name of the Cloud Shell. It's not a type of a shell, right? So don't take this. Okay, so we have a new type of a shell. They're just calling it a Cloud Shell. That's it, because they're giving you a server. The server is the Debian. So Debian, I think it would be the Debian 10, and we'll see the code name, which will be the Toy Story character name. So it's a type of Debian Cloud Shell, and it's not a shell like this one, like Bash and Fish and K and Z. It's just the name of the Cloud Shell. So don't get confused, or don't think that this is also one of the type of shell which is created by Google. It's just the name of their application that they're calling it. So I'll come back to this one. So they have given an editor like VS Code. So I'm gonna, I don't need the editor at this moment right now. So I'm just gonna close the editor or just uncheck on the pencil icon, and that's it. It's gone. So the first command that I'm going to show you here is that you can hit enter as many times as possible. Is the font okay, or I need to increase the font? Let me make the largest so it's easy for you guys to see. Right.
Yes, perfect, perfect.
Okay, good, thanks. So the first command that you want to use, that I use, is the clear. What clear going to do is clear the screen, but actually it just pushes everything to the top. So it's not completely wiped out or erased. You can always do scroll up here. Since it's a browser based, that's the reason why I'm not saying this, because Google is actually getting rid of it. But if you were to do that on some kind of a server, you will be able to pretty much see that everything that you have is just shifted upward. It's not completely erased or gone. You have all of those there. The first command for the navigation point of view that we want to start is the ls command. What ls command is going to do is so we'll start with the navigation command. So we have the first ls command. Ls command, this stands for list. We'll see that, like where to see all the different variation. What the ls command going to do for you is just it will just show you everything that is available in your current directory. So there is current directory is there, and I'm actually sitting somewhere, right? And that somewhere, let me just draw that so you guys can easily understand and relate. So this is my root / and this is the home, and then so this is the home, and then this is the name of my user called Sheikh Assets. So right now I'm sitting here. So my path is actually from here, here, and here. So there is a command called pwd. And if I want to run that command right now, sitting here in the pwd, what is the output I will get? The output I will get is / home / like that is what I'm going to get, because I'm sitting here right now. This is my location. Currently, I'm sitting here, right here. So if I run the pwd, So what I get, and this is this a relative path or absolute path? You should be able to tell me that, right? It is the absolute path. If you said absolute path or thought absolute path, then you're right. If you are using Mac, you could pretty much do this way as well to just get started, or you can just follow all the command that I'm using here. I mean, and another thing, you're gonna have some kind of a terminal in there, which I'm assuming you should already know that because you are using Mac, so you're gonna have that. People using Windows, they may not be familiar with the PowerShell, but on Mac also you can follow exactly the same way that I'm doing. Or if you don't want to do a cloud-based, you can use your terminal that you have that is coming with the Mac, because all the command that I'm using is, it should also be available in the Mac. And I would better say, you know, don't use that, because there might be some command which may work here and it may not work on the Mac, and unnecessarily we'll have to spend time trying to troubleshoot your issue. So better follow whatever, you know, where I'm doing it, so you'll not have a lot of issues. So this is what you should be able to imagine when you see something like that. You don't want to get lost here, right? One more thing that I want to get. So I've copied this thing, you know, because this is where I'm present at this moment. So within this, when you see this, right, this is called your prompt. You have on your prompt, and the informations that are available here, right? This information is your username, and this information is generally going to be the host name, and this tilde sign, right? And again, this has like a various pronunciation, so you don't need to be very conscious about pronouncing it correctly. So this is the username, whoever is logged in. This guy, generally the Cloud Shell that we see here, is generally going to be the host name or server name, right? Whatever the name of the server that we have. In our case, Google is just simply calling it Cloud Shell. But if we are not on the Cloud Shell, we'll have some different name there. This sign, you know, it's a tilde, tilde. When some people, you know, have a various pronunciation, it's written like this. So it's a tilde, whatever you want to call it, based on you know, what type of, again, people you are interacting with. This actually always represent the logged in user's home directory. This guy is the home directory of logged in user. So right now, who's logged in is Sheikh01, right? So the home directory of the Sheikh01 is going to be always, I mean, you can always construct any user's home directory except root, because root user gonna have a special home directory, which is just going to be /root. And it is on non-root user, it's always going to be home and then /username, right? So this tilde always represent, this tilde is basically it's equal to this. So tilde equal to this. If you are logged in onto the root, then this tilde will be equal to /root, because that's the home directory, or that's the user directory or staging area, I like to say that, of the user, whoever is logged in. So if you are logged in as a root user, then that's going to be your you know, your home directory or staging area. And if you're logged in with the root non-root user, then that's going to be that. Since it's starting with a /, then that becomes the absolute path, right? So ls is going to list whatever is present in my directory, and right now there is just one file that I see, which is this readme-cloudshell.com. Probably you'll also see that if you're checking it for the first time. Anybody has a question? Hola Latunji, I see your name. If it's accidental, then yeah, you can.
Oh yeah, sorry, I'm okay now. Sorry.
All right, and so we have seen two commands so far: ls, pwd, and we've also seen the clear. So pwd, let me write it down here, and then we saw clear as well. So let me use the clear command again. What clear command is gonna do is just clean the whole screen. You can use the Control-L as a shortcut for this one, so it's a lot easier, or Command-L if you're on a Linux, if you're on a Mac. So Control-L or Command-L, it's a shortcut for the clear. I'm not sure if that's a Command-L for the Mac, but You can maybe look out or just simply type the command. That is the clear is the command, right? So ls pwd and clear. Okay. The next command within the navigation, what we want to know is commands that's going to create a directories. So first I'm going to use the command that is to create the directory, and then I'll use the command to create the file. And before that, there is always a manual. When you buy a product, there is always a user guide or user manual is presented to you by the maker of that product, right? If you buy a refrigerator or TV or mobile, there will be a user guide or manual guide through which you can read and understand how to use that particular product. In Linux also, there is a man command is available. Man command is just available for the manual. Actually, there is a thing. There is a two commands available. Whether it's there are two commands are there for help for user guide. One is help and second is man. Now, when to use when command, right? That is the question. Should I use, so I want to read the ls, the manual page of the ls. Should I use the help command or I use the man command? Now, anything that is a program which is not coming as a built-in with the kernel, then you should use man. So anything that is program or anything that is built-in, we should use help. Now, how do we determine whether it's a program or it's a built-in? There is another command for that, and that command is the type command. So type command is actually going to tell whether the command for which we are looking for a user guide or command for that we are using a manual, whether that is a built-in command or it's a program command, right? So let's go and see that in action. So right now I want to know more about ls, and I don't know ls is the whether ls is a program or it's a built-in. So what I'm going to do, I'm going to say type is the command, and it takes one argument, and that argument is going to be the name of the command. So I'm going to say ls. So ls is the alias, and there is an option I can pass ls a, and it will tell me whether it's a program. So it's all program. So first is the alias, which is we can completely ignore, right? It's a so for now let's just ignore. We'll talk about alias later. Just there are two programs are available. One is available in user bin ls, another one is available in bin ls. So if we come here, right, the different path that we saw, one is available in the user, and within the user we have another directory called bin, and another one is directly available. The ls is directly available here as well. So we have two ls. One is here, and another one is here, and then we have here. It's getting too congested, but yeah. So there are two ls there, and the way which command, when I say ls, which command is executed, whoever comes first in the list. So this one is coming first, so always this command will be executed. Unless for some reason this command is not accessible or is corrupted, it doesn't work, then it will fall back to this command. So basically type is the way to find out whether it's a program or it's a built-in. So it say ls is user bin ls. So this is actually pointing to a program. It would have said ls is a built-in, that's it. If it was built-in, ls would have said it's a built-in. Now type is also one of the command, right? And I can find out whether type is the program or the built-in. I can do that as well. So simply type -a and again type. So look at that. It says type is a shell built-in. So type is the shell built-in. And if I want to see the help or the manual or the user guide of the type, all I have to do is help and then type, because it's shell built-in. And it actually tells me everything. Welcome to the cloud shell. Type help to see the message, type message. Okay, for some reason on the cloud shell, actually that is not working out, but this would have been the way to do that. For program, we'll see that. I mean, there are few things that we may want to ignore because it is actually created in a very special way. Actually, it's a container that is running here. So there will be few commands that may not work, but you just have to remember right now, the point to remember here for us is this. Whether we use man or whether we use help, it's a built-in, then we will use help. And I will show that to you when we actually move to a server which will be created by us. So probably Mac is coming up with as a built-in for you. That's why it's showing you, right? So you can say, you can see help that, and with the type, you probably should be able to see ls as well. So here ls is not a built-in. So if I want to say the more about ls, I'll have to say man and ls. And here we have, so a very important thing to know here is how to read this. And the way to read it, I mean, this just gonna talks about what it does. So list directory content. So anything that is available in your directory, the content, it will list it down. So that's something we have seen. If you want to see something, we just type ls and we do that. Synopsis is the usage. How do you use that, right? So you type ls and then option. Anything that is present in the square bracket, it's optional. So this option is optional. If so, you provide, you don't provide, totally up to you. And that's the reason why when I just type ls, it works. It doesn't complain about, okay, you have not put some mandatory argument along with the ls. It's not saying that way. This 3 dots called ellipsis, which means you can provide more than one argument. So more than one option you can provide, and all of these are optional. Again, with this same, we have the file as well. Now you can actually provide the name of the file as well. And here, when they say name of the file, basically they mean a directory. Like I said, in Linux, everything is a directory. And here in the synopsis, actually it is telling that this is the, this is going to be the file which you can specify name of the directory or the folder. And you can specify more than one directory or the file as well. So that's the way to read it. Anything that is in the square bracket, which is optional, if you see 3 dots, which means you can provide more than one of the same, whatever you have, whether it's option, whether it's a file. Anything that is going to be without any square bracket, then that is a mandatory thing, and you have to provide that. And we'll see later, right? I'm gonna actually coming back to this man again and again, just so you understand. And these are your friends. I mean, when you work with something, you just have to pretty much do this, go to the help man and understand that documentation is your best friend. It has everything what you want. All you have to do is just take out some time, read it, and then execute it. I mean, that's the way, that's the idea you have. So we have different options. We have -A, that's, first of one of the option, which says do not ignore entries starting with the dot. In Linux, anything that starts with the dot is the hidden file, right? So if we type ls-a, let me get out of this. Okay, I'm out. So Q, you have to just type Q, and that will actually take you out. So if I type -A like this, so I can see more than one. If I type ls, all I see one, and see how many hidden files I have. Dot backup, bash history, bash logout, bash rc, cache, config. All of these dot files, they are hidden by default. I mean, that's the way you want to do that. And by default, ls not going to show you. So you have to supply these options, right? So that's the way, to work with the hidden files. And let's go. The very common pattern with the ls is always -L. It will show you as a listing, and there are actually more information printed here, which we will talk about that later. What are these information, and everything that you see here, we'll go over all of these in detail. So this is the one option you have, -L, which you could have found in the man page. So if you scroll down with pressing a down arrow, you could see that, and it will be somewhere, because it's alphabetically arranged. So here, use the long listing format. So I'm using -L, and I've also showed you -A as well. So I can actually use ls-L-A, and look what happens. I can see all the hidden files, and the format is listing. So what I'm using -L and -A. I can actually combine this one. So instead of, I'm gonna clear the screen so everything comes on top. ls-LA. So I've combined this, and this will work exact same way the way it had worked previously. So you can combine this as well. And there are different variation that people uses. The most common one people uses LRPH, which actually gonna show you the size of the file in the human readable format. Right now, these are all bytes, right? And this is okay because it's pretty small file. So it's like 8,000 byte, probably 8 KB. But when the file size is in MB or in GB, you're gonna have a very massive number, a very big number. and that's not very easy on the eyes to calculate immediately. So H is actually gonna put this size in the human readable format. R gonna arrange the date recursively, and L, we know the L, and T is for the time. So it will arrange as per the time. Whatever is the latest will be shown on top, but when you put R, it will do the recursive. So this is the very common for a common variation of that people uses. So right now, since I just have a one file, that's why I don't see a lot of stuff. But I can put this as well if I want to see the hidden. So whichever file is the latest is actually here in the down. You can see that timestamp as well, because T is for the time. It arrange everything. It will sort everything to the time. I mean, these all you can find all this information right in the man page. And how to get the man page, you know that as well. The next command I'm going to use is called a makedir command, which is the command that we will use to create a directory. Right. So you know what? Let's just see what is the makedir command. Whether it's a type. What is the type of this makedir command? It's a shell built-in or it's a program. So it is also a program, right? So if this should also have the man page. So we have it here. And now very important thing to know that the name and synopsis. We have makedir again. We have the option ellipsis, which means we can supply more than one option to that. And look at this directory now. It is not wrapped with a square bracket, which means this is mandatory. You have to supply a name, right? So you have to supply the name, and that will be your directory. You can supply more than one because you have ellipsis here, right? So it will create more than one directory. Right? Let me go and show that to you. And when we talk about option, there aren't much options available to this makedir command, right? It's pretty small manual page. All you have -m, -p, -v, -c, and this sort of stuff. So let's use makedir. I'm gonna create a directory. So the mandatory argument, I have to supply the name of the directory. If I run just like that, like how I ran ls without any argument, it actually didn't complain. Rather, it was executed successfully. But with the makedir command, actually it errored out. It says missing operand. So I'm missing the operand here, which is the argument which I need to supply after the makedir, right? So that's what. So right now I'm present here, right? And I'm gonna create. I'll be creating this. I'm gonna creating the directory here. So what will happen? I'm going to create a couple of directories. Right? One is here. So basically, I'm gonna have a directory. I'll call it Linux 03. Or I'm going to call this nodes, right? Something like that. So I'm going to, inside this one, I'm going to create two directories. So first, Linux 01, so 03. Now, if I do ls, here we have the directory, right? So here we have the directory, here we have the file. Now, I can create another directory called nodes. So make the nodes. I have it here. And if I want to create multiple of directories, so I can create backup and backup 01, right? Because it says it accepts more than one directory name, right? The three dots, those are present, and that actually work. If I do ls, I have a couple of directories now: backup 01, Linux. And if I clean the screen, Control L, ls-l, if I see that. So one thing to actually note here is everything, all the directories are actually given with the color, right? So they are represented with the color, but you may or may not see the colors all the time. You don't see color here, which means now you can tell that, okay, this is not a directory, that's why it's not a color, right? So while that assumption is correct, and in most of the system, you're going to see that color thing, but there will be some distributions or some distros where you don't see the color. So if you're going to rely to understand, okay, this is the directory because it has color, then you might fail yourself on some distribution. What is the best way to know is this: the first letter D stands for directory. So if you see the first letter as D, which means that is the directory, right? And if you don't see that, then it's going to be it's not going to be a directory. So there will be a very handful of letters that you'll see that is that are beginning with. So I'm just gonna take a screenshot of this, and put it inside our paint or our whiteboard. So the first letter is important, and this is where you wanna keep in. This is the way to determine whether it's a directory or it's a file. So you have this when you don't have a letter rather than color. So this means it's a sorry. So this is directory. D stands for directory. Dash is for the files, and we also have one more. You might see that L would be for the links, and we'll see that links as well later in the later classes. Okay. So I think for this one, right, we have the very basics. I mean, we still have a lot of things to do that from the navigation point of view. But the important thing here would be to understand or imagine in your head where you are sitting here in the file structure, right? And this is very important because things from here on now gonna get not very complicated, right? It's only get complicated for you if you don't remember this, right? So this is very important what we did today, and what we did day before yesterday as well. I mean, as a non-functional things are also important. From here on, we'll be doing a lot of classes, and time we'll come back to the notes as well, because like I said, unless you get very comfortable with those seeing everything on the shell or terminal, the black and white stuff, and your head doesn't start spinning because you don't know where you are, and things might gonna get little complicated as well. Not now immediately, but over time it will. So if you have a very good understanding of where you are and you can quickly switch yourself from here to there, then you're not gonna have a lot of issues. But if you don't, then you're gonna struggle and you make mistakes as well. And I'll tell you few ways by which you can avoid the mistake, or you can avoid the mistakes which might lead you to the termination as well, because there are mistakes that people have done that led to the termination of the jobs as well. So you don't want to kill the person, and those mistakes are as good as killing the person, right? It is that severe. So I'll tell you all the different ways that will keep you safe, but the more you can imagine in your head, the better it will become for you to actually work with it, right? So we'll see more about the navigation and more about the commands, because that's what we had these foundational theory lectures where we did a lot of theories, but from here on we'll do a lot of labs, and we'll have to do the theories as well, so to explain you guys how things are working behind the scenes. Okay,